this is ye room, and let us place ye ball here. How do you say the position of the ball? To tell the position of an object, you need a reference. If I choose this corner point as a reference, the ball is opposite to this corner. Draw a vector from here to this position. Let's say the vector is r bar. Let us understand the coordinate system of this vector. If you take this corner as reference as point O, then this is x-axis, this is y-axis, and this is z-axis. Coordinate system of O is O of x, y, z, since it is the beginning point. X equals to 0, y equals to 0, z equals to 0. Now, how do you represent the ball position in this coordinate system? Let's say ball position is point P. The ball is this much distance on x-axis. Let's say the distance is x. Similarly, the ball is this much distance on y-axis. Let's say the distance is y. Similarly, on z-axis, it is z. The ball position in this coordinate system is P of x, y, z. Here, this vector indicates position of a point, that is P of x, y, z, in this coordinate system. Therefore, position referred as a vector that indicates the position of a point in a coordinate system. This is the position vector, r bar. This is the unit vector in the direction of x-axis, denoted by I bar. This is the unit vector in the direction of y-axis, denoted by j bar. Similarly, this is the unit vector in the direction of z-axis, denoted by k bar. Now, let us understand how do you derive the position vector r bar in this coordinate system. Position vector is sum of the x vector, y vector, and z vector. To get x vector, unit vector of x, that is I bar, into x. To get y vector, unit vector of y, that is j bar, into y. Similarly, to get z vector, unit vector of z, that is k bar, into z. Magnitude is modulus of r bar, that is square root of the sum of the squares of coordinate points. Unit vector of position vector r cap is equal to vector r bar divided by modulus of r bar. This is the unit vector in the direction of vector r bar, denoted by r cap. A vector that indicates the position of a point in a coordinate system is referred as position vector. Let us understand what is displacement vector. Let us say this is the initial position of the ball, P. Coordinates of point P is P of x1, y1, z1. Let us say this position vector is r1 bar, which is equal to x1 I bar plus y1 j bar plus z1 k bar. From this initial position, if the ball bounds to a distance, let's say, this is the final position, q. Coordinates of point q is q of x2, y2, z2. Draw a position vector to final position, let us say r2 bar, which is equal to x2 I bar plus y2 j bar plus z2 k bar. Draw a vector from initial point P to final point Q. Here, the body displaced from P to Q, it can be represented by a vector PQ bar R by vector delta R bar, which is known as displacement vector. Let us understand the derivation of displacement vector. Displacement vector is delta R bar equals to final position vector minus initial position vector. Delta R bar equals to R2 bar minus R1 bar. On substitution, we get following, which represents displacement vector. Now the magnitude of displacement vector is modulus of delta R bar, which is given as square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Let us understand how to multiply a vector with a scalar. Let's say this is point O, and this is the coordinate system of point O of 0, 0, 0. Draw a vector A bar from this point, and the final position is A of x, y, z. Let us take a scalar. As you know, scalar have only magnitude. Let us say n. Now let us multiply vector with scalar. Vector is A bar and scalar is n. The resultant of this multiplication is also a vector. Let us say B bar. This is the direction of vector A bar. How do you say in which direction the vector B bar is? The resultant vector direction depends on the magnitude of the scalar. For better understanding, let us see different cases for n value. Let's see case 1, when n value is positive. We have B bar equals to n into A bar. Here A bar is positive and n is also positive value. Therefore, the resultant vector B bar is also positive. So we can say B bar is in same direction of A bar, R. The resultant vector B bar is in parallel to A bar. Now, the magnitude of B bar, again, depends on positive value of n. Let's say n value is 2, then B bar equals to 2 into A bar. Here, the magnitude of B bar is 2 times multiple of A bar. R. we can say modulus b bar greater than modulus a bar for this case. This relation holds for n values of 2, 3, 4, and so on, which are positive. Now, let's say n value is 1, which is also positive. Here, b bar is one time multiple of a bar. The magnitude of b bar is equals to a bar. Observe here. The magnitude of b bar and a bar are same and both b bar and a bar are parallel to each other for this case. Now for n value between 0 and 1, which is also a positive value. Let's say n equals to 0.5. Then b bar equals to 0.5 times multiple of a bar. Here, the magnitude of b bar is 0.5 times magnitude of a bar. In this case, for other values of n, magnitude of b bar is always less than magnitude of a bar. Observe here. The magnitude of b bar is less than magnitude of a bar, and both b bar and a bar are parallel to each other. Now, let's say n value is 0. Then we have b bar is 0 time multiple of a bar. Here in this case, b bar becomes a 0 vector. Observe here. In this case, the magnitude of b bar becomes 0, and its direction is undetermined. Now let's take n value as negative value. We have b bar equals to minus n times a bar. Observe here, b bar is in opposite direction to a bar. If n value equals to minus 1, then we can denote b bar equals to minus a bar, or a bar equals to minus b bar. But magnitudes modulus of b bar equals to modulus of a bar. Observe here. Both b bar and a bar are in opposite direction, but their magnitude is same. Here, b bar and a bar are called antiparallel vectors. On conclusion, by multiplying a vector with a scalar, the resultant is also a vector, whose direction depends on positive or negative value of scalar.